Okay, so in the previous video we found the stationary points of y is equal to 2x minus 3 over 2x squared minus x minus 1. They appear to be 5 halves 2 ninths and 1 half 2. So hopefully this bit of information will help us when sketching our curve. So first thing we're going to look for are vertical asymptotes. So that's when the denominator is 0. So we want to solve 2x squared minus x minus 1. So you can do that either by factorising or by using quadratic formula. So 2x squared, well, if I rewrite it, we've got 2x minus 3, 2x squared minus 1, 2x squared minus x minus 1, sorry, will factorise to 2x and x, and we're going to have a plus 1 and a minus 1. So we're going to need minus 1 and plus 1 there. So the two asymptotes, vertical asymptotes, will occur at x is equal to minus a half and when x is 1. I'll put x equals 1 there. So they are the vertical asymptotes. So we have minus a half and x equals 1. Okay. Now, we're also going to need to know where it's crossing the x-axis. So that's when the numerator is 0. So that will happen when we're at 3 halves. So x is equal to 3 halves. It's about there. That's where it's crossing the x-axis. Now, if we're looking for a horizontal asymptote, then what you want to do is you want to divide through by the largest power of x squared, largest power of x, which is x squared. So we're going to get 2 over x minus 3 over x squared over 2, take away 1 over x squared, take away 1 over x, take away 1 over x squared. Now as x gets very, very large, these 4 fractions will all tend towards 0. So what you'll get is 0 on the top and 2 on the bottom. So the horizontal asymptote is y is equal to 0. So it tends towards the x-axis. That's our horizontal asymptote. So now, are we ready to start sketching this curve? Well, we've still got a little bit of information that we could find. We can work out where it crosses the y-axis, for example. That's when x is 0. So when x is 0, y is going to be, well, we've got minus 3 on the top, 0, 0 and minus 1 on the bottom, so that'd be 3. So we know that it crosses at 3 on the y-axis. Okay? Now, how about stationary points? So we've got one at 5 halves, 2 ninths, and we've got one at 1 half 2. Now 1 half 2 will be somewhere here, okay, between the 0 and the 1, so 1 half 2 will probably be around about there. So that must mean that the curve must have a minimum point there, so the curve looks something like this. Okay, so that's my stationary point, 1 half 2. Let me just put the 3 there. Now I've also got the stationary point at 5 halves 2 ninths, which is somewhere over here. So the curve will look something like this. It'll have a stationary point somewhere, probably a little bit lower down than that, and then tend towards y equals 0. So this point here will be your 5 halves 2 ninths. Now, over on the left-hand side, to the left of minus a half, we don't know whether it is in this section or this section, top half or bottom half. Now, in order to determine that, we could just choose a negative number. So if we chose minus 1, for example, then we're going to have 2, minus 2 take away 3, so we'd have something negative on the top. we'd have minus 2 lots of minus 1 plus 1, which is negative, and we've got minus 1 take away 1, which is also negative. So we've got 2 negatives on the bottom, we'll make a positive. Negative over positive would be negative. And so the curve must be down here. You could also substitute in a point, if you like. So we substitute in x is minus 100. Minus 100 rather. Then we're going to get 2 lots of minus 100, take away 3 on the top, divide by minus 100 plus 1 times minus 100 take away 1. And then you get minus 203 over 9999. So it's negative, so it is in that bottom half. So that's how we can use the stationary points to help us determine how the curve will move.